See, in the parallel plate capacitor, we have a parallel plate. Here we have plus minus. Okay. What will be net electric field? Your net electric field will be equal to sigma upon 2 epsilon naught. For this and for this also, it will be same, sigma upon 2 epsilon naught. We have already discussed about this formula in the first chapter. So your electric field will be equal to sigma over 2 epsilon naught, right? We have one more formula for a potential difference, yeah, or you can say the formula for E. Now, we have formula for E. E will be equal to V over R. R is distance. You can represent it by D. Voltage per unit distance is your electric field. Electric field is volt per unit distance, volt per unit meter. So now what you can write in place of what you can write V equals ED. In place of E, you can write this point. Yes, you can write sigma over 2 epsilon naught into D. Sigma over 2 epsilon sigma over 2 epsilon naught into D. So your V value is sigma over 2 epsilon naught into D. That means what? That means your V can be written as see, in place of sigma. What is sigma? Surface charge density. What is surface charge density? Charge over area. That means V will be equal to what? V will be equal to charge over area multiplied by D over 2 epsilon naught. V is equal to Q over A into D upon 2 epsilon naught. So we can write anything here. Yes, you can write in place of V. I am writing V. In place of Q, you can write quick climbing valley, that is CV into D over 2 A epsilon naught. That means V and V you can cancel, and you will get the value of C as here. This 2 will not be there. It's my mistake. This 2 will not be there. This 2 will not be there. See, why 2 will not be there? 1 plus 1 will be 2, and below we have common 2. So this was just a mistake. Yes. So C will be equal to what? It will be equal to A epsilon naught over D. A epsilon naught over D. The energy will be E is equal to half CV square, or energy will be equal to Q square over 2C, or energy will be equal to QV over 2. Half CV square, Q square over 2C, QE is equal to Q upon V. For this, we don't have any derivation. Derivation was from till here only. You have to, in textbook also there are no derivation for energy, like half CV square, how it comes, Q square upon 2C, how it comes, that E is equal to QV upon 2, how it comes. We don't have any derivation for this. Okay, once again we'll see this thing. What we are considering, we are having a parallel plate capacitor. How a parallel plate capacitor will look? It looks like this. Okay, this will be positive, this will be negative. Okay, so your net electric field because of positive plate and because of negative plate. Your net electric field will be what? This will be equal to sigma over 2 epsilon naught, sigma over 2 epsilon naught. So this will be equal to what? This will be equal to sigma over only what? Only epsilon naught. So your E formula is this. Okay, now we have formula for E. The another formula is V over distance. That means we can be written as E into D, and what is E? E is sigma over epsilon naught into D. In place of epsilon, you can write charge over area into D over epsilon naught. So this will be equal to what? In place of Q, you will write CV. V and V will get cut. So therefore, C will be equal to A epsilon naught over D. Okay. What will be the energy? Energy will be half C V square. This was the formula, and for this we don't have any derivation. Or you can say energy will be equal to Q square over 2C, or you can write energy will be equal to QB upon 2.